Bismillahirrahmanirrahim. Dear viewers, in this tutorial, we will model 5-storied commercial building having one basement. This is the plan of the commercial building and this is the elevation. From here, we will get floor heights. First, we will isolate column and grid layers so that we can prepare the TXF file to import into Proto structure. Now separate the column and grid layers. From here copy these layers to new CAD window, then paste here. From here we will make it DXF file and we will save the DXF file so that we can import into Proto structure. Now close the drawing tab, open Proto structure program. From here create new project, type the project name, then select the template with relevant code which we want to use for this project. Click OK. Now go to DXF import option. From here load DXF file. Now select the layers. Using this, grids and columns will be automatically generated in Proto structure. Other things we will keep same as it is, then click OK. Here the retaining wall section was drawn with column layer, so full rectangular section generated from retaining wall boundary. So we will delete it. We can use external reference drawing to model other elements in Proto structure. Here I am using same DXF file as external reference drawing. We can see the drawing is not located at exact origin of the main model. We can move the reference drawing easily like this. Now we can model lift core wall following the reference drawing. Here we will provide the thickness of wall and offset over the center line or grid line. We have not provided any eccentricity or offset. We are modeling the wall keeping grid in center line. Now we will adjust the wall offset using up, down, left, right arrow of the keyboard to make the wall aligned with the reference drawing. And we can adjust the extension of wall from the connecting nodes like this. Now create more grids to model the other portion as per reference drawing. Select the wall option, then customize start and end offset of wall. Not like this, so modify the offset like this. It will match with the reference plan. Similarly, down part like this. Then model other lift core in the same way. Here we can double click on existing walls to model new wall similar to that wall with similar offsets like this. Now model a small portion of walls same like before. Now we can merge the walls to create a single element in the structure. We can see our model in 3D view. Save the model. From View tab, we can create multiple windows side by side. We will create level for guard room as its foundation level above the basement level. This is the guard room in plan. This is in structural layout. Go to edit story. Here we will edit the story height. First one 3.2 meter. At that level, clean beam for guard room will be there. Then we will insert another story 800 millimeter above this level. So these two combining the basement floor level 4 meter. We can select 3.2 meter level as intermediate level. Then select 4 columns of guard room and replicate or copy it to next level. Now delete guard room columns from basement level as per the elevation. Foundation depth for basement level 80 centimeter and the guard room foundation level also 80 centimeter down from the clean beam. Now we will assign support for this guard room columns. We will define new support and then assign support to this 4 columns like this. Now close. In this way we can provide support in different level in proto structure. Now select other columns to replicate to next story. Then we will delete the members from lower story. Then first we will select columns only, deselect the walls, then go to list. From here we will change the length story from 1 to 2. Similarly, select the walls and change the length from 1 to 2 so that these members can continue from basement roof to bottom of the basement. From edit story, we can provide the description for basement roof level. We can provide level marking so that in detailing the beam, column and other members will be identified by those level mark. Click on OK. Save the model. Now we can model basement wall following the reference drawing. Provide the wall thickness and other parameters. Similarly, model this basement wall all around the plot line and then select the retaining walls to change their length from single story to double story like this. Now we will model beams at basement roof level. I have increased the speed of the video because modeling of beam is easy and same like before we have seen in previous tutorials. If you are new to prototype structure, you can check my previous tutorials on different buildings. You will see there how to model beams, and from here also you can understand how we are providing parameters and modeling the beams. Now we will model stair. Program will ask to define load cases before modeling stair or slab. We will define preliminary load cases, dead load and live load. Then we will start modeling of stair or first slab in model. Here in this level, stair is getting only 80 centimeter height. So we have to go to basement level to model the stair up to 3.2 meter height. Then we will change the floor height at stair model from 3.2 meter to 4 meter so that it can cover basement level to basement roof level. Now here we can see the stair top level at 3.2 meter level. So now double click on this and then provide floor height 4 meter to adjust the stair top level at basement roof. Now it is okay. Here we can edit step number, waist slab thickness, landing width and other things as per architectural drawing. Then we can provide the loading values from the load tab. Click on OK. Now go to basement roof level. Here we will model slab, basement roof slab, provide slab thickness, then loading values. From the list of occupancy category, we can give the input for live load. Use beam region to model the slab. In this way, we will model all the slab for basement roof level. Modeling few extra beams to cover the basement roof level outside the main building area. It will reduce the slab span length. Here, this slab area we can separate using additional beam. Now model the separated slab in those areas. We can increase the slab thickness for large slab areas. For other small slab areas, we can decrease the slab thickness. Now save the model. Then run building model check to be confirmed that there is no warning in the model. We can view our model in single line view or analytical view like this. Now we will add stories using the option in insert story. Here already we have inserted two story or two levels. Now how many levels need to be added? We can see here 5. So 2 plus 5, total 7. Here we have to provide the total number of story to get extra 5 levels. Height providing 4 meter for typical floors. Ground floor height is 5 meter. So we will edit ground floor height. Here type 5 meter, 5000, and other floors 4 meter typical floor, and top floor, that means stair head, that is 3 meter. We can provide the description for different levels: ground floor roof, first floor roof, second floor roof, like this. Now we can provide the number of rigid basements. Basement floor we have divided into two parts. So for basement floor we will provide number of rigid basements 2. Now check the plan is in story 2. Then go to generate story. From story 2 to next story, click on OK. Now delete the retaining walls from this new story. Here we can see the column and wall members having double height because we have assigned member length 2 for continuing 2 floors. Now for this new generated members we have to change the length from 2 to 1. Now need to explode the lift course so that we can edit lane number from 2 to 1. Then select the walls, then go to property table, lane number from 2 to 1. Now again merge the walls to make it single lift core. Now go to building check to check the model if there is any error or warning. There is no error or warning, so now we can go for next steps. Now we will delete the extra portion of slab and extra beams according to our ground floor roof level, and we will prepare guard room roof level and basement roof level according to our drawing. Now we will model stair for ground floor level, same like before. Modify the parameters for steps, slab thickness and loading, then click OK. Then model landing beam for stair landing. Model slab for guard room roof, like this. Now replicate or copy stories from this floor to next floor, like this, and delete the guard room part for this floor, and also delete the splitted beams from this floor. Now model a new beam here, then go for building check to be confirmed that there is no warning or error. Here somehow repeating ID error found here, so we will check the level of beams and we can modify the level to remove the error. Edit the beam level, then apply. Now go for building check. Now we will see the error is removed. Add the landing beam for this floor also. Now we can make typical story similar from edit story option. Select the stories and define stories as similar. Click on OK. Automatically the members of typical floor generated to other similar floor. Only landing beams we have to model manually because landing beams are not replicating or copying to other floors. Now replicate story to last story level, that means stair top level. Here we will delete unnecessary beams and slab according to stair head plan, and we will prepare the stair top floor level with new beams and slabs. Now we will add partition one load on floor level. In prototype structure partition load library, we can add material type and wall thickness to calculate wall loading automatically. We need to provide wall thickness unit weight, then using that wall we can apply load by providing wall height only. Here in Oman, wall unit weight is 14.225. Now select the beam, go to load editor. From here we will apply the wall load. Here we will provide the wall height, then click on insert. Now click on OK. For being similar floors, the wall load came to these three similar floors. Now right click on the beam and then select copy load. From filter select wall load, then select new beam and paste the loads. In this way we will finish applying wall load on all the floor levels. Now we can make one floor not similar to edit the roof wall loading differently. Now in the roof level we will edit the wall loading on beam like this. So wall loading finished. Now we will go for building model check. There is no error in the model, so our modeling of the building has been completed. The analysis and design part, same way we can follow the previous tutorial which have been uploaded in my channel. You can follow that one. In the next tutorial I will start another real project. modeling, analysis, design, and also I will try to cover the calculation report preparation. So subscribe the channel, stay tuned with the channel to get new important tutorial.